Volcanoes. This course is brought to you by Gilad James Mystery School. Learn more at giladjames.com. Introduction. This is the introductory lecture of the course Volcanoes, Geological and Geophysical Setting, Theoretical Aspects, and Numerical Modeling, Applications to Industry and Their Impact on the Human Health. In this lecture, the research themes studied in this course have been introduced referring to the geological and geophysical setting of volcanoes, pertaining, in particular, to the correlation between seismic and volcanic activity in volcanic edifices of southern Italy, Somma-Vesuvius, carried out on a regional scale, the volcanic emissions of the submarine edifice of the Tagoro volcano, Canary Islands, Atlantic Ocean, and the corresponding implications on the chemical and physical properties of the oceanic water, the volcanological studies on the base of the volcanoes and the discovery of a new volcanic edifice, namely the Hiyamizuyama volcano, allowing to evaluate the long-term variations of volcanic and magmatic processes in northeastern Japan, the volcanic eruptions in Indonesia, a land hosting 147 volcanoes, 76 active volcanoes, spreading along the islands of Java, Lesser Sunda, Sumatra and Celebes and mostly characterized by stratovolcanoes, and finally, the geologic, petrographic and geodynamic study of the layered gabbroids of Pekulney Ridge, a complex volcanic structure located in northeastern Russia. Moreover, in this course, significant theoretical aspects and numerical modeling of volcanoes have been addressed, including, in particular, the volcanic dynamics of the convective heat and of the mass transfer in the seismo-focal areas of the Kamchatka Region, including the related volcanic arcs, the modeling of the elastic deformation of volcanoes through the development of computational tools for inverse analyses of geodetic data, which have evidenced the mechanical complexity of the volcanic systems, and finally, the mechanical aspects of the magmatic chambers and their relationships with the fluxing of CO2, referring to the Yellowstone magmatic chamber, whose large volume has required additional large volumes of magmas and fluids in order to trigger volcanic eruption. In this course, significant applications of volcanic studies to the industry have also been presented, focusing, in particular, on the use of volcanic scorias, versus, and natural pozzolans as cement replacement in the construction industry based on the concrete mixes by analyzing their setting times, the compressive strength, water permeability and chloride penetrability and, moreover, on the use of volcanic glasses as adsorbents for industrial aims and scopes, being materials displaying a low thermal conductivity, a low density and a high resistance to fire in perlite aggregate plasters. The volcanic glasses have also been often used as starting materials in the synthesis of clay minerals, as smectites and zeolites. The impact of volcanoes on human health is significant, referring to both the volcanic deposits and to volcanic emissions. In this course, the impact of volcanic emissions on human health has been mainly examined, highlighting that exposure to volcanic emissions can influence the health of people living in the surroundings of the volcano in many ways: dermal and ocular irritation, cardiologic and pulmonary exacerbations and cancer. Moreover, volcanic ashes which have been deposited in a subaqueous environment may produce significant variations in the chemistry of the surface waters and may increase the risk of exposure to metals by drinking that water. Volcanoes represent geological structures forming on the Earth's surface in the zones where an emission of magma verifies, that is, a volcanic eruption. Many volcanoes have an outer shape of a conical mountain, constructed through the superimposition of the erupted products. The inner part of the cone is crossed by one or more volcanic conduits, representing the last tract of magma uprising. These conduits open outward through the craters. When the magma uprising happens for a long time along the same conduit, the products of different volcanic eruptions accumulate around the same, forming a central volcano. After that, the volcanic eruption terminates and the volcanic conduit remains empty, the volcanic crater occurs as a deep cavity. Along the central conduit, the uprising of new magma may become very difficult in a high volcano or having the conduit filled by solidified magma. The magma tends to accumulate and pushes along the walls of the volcano up to fracture them. The fractures and faults represent one way out on the flanks or at the base of the volcanic cone, where parasitic vents consequently form. Volcanoes may have different shapes and dimensions, strictly related to the type of eruptive activity. The effusive eruptions tend to grow a volcano through the accumulation of superimposed lava flows. The explosive eruptions may, on the contrary, remove whole parts of volcanoes. A stratovolcano is typically formed by the superimposition of volcanic products erupted by both explosive and diffusive eruptions. The flanks of these volcanoes have steep slopes. Remnants of previous craters, partially destroyed by the strongest explosive phases, have often been individuated. The dimensions of the stratovolcanoes are often relevant but smaller than the ones of shield volcanoes. Important examples of stratovolcanoes in Italy are represented by the Etna and Vesuvius volcanoes, while between the largest volcanoes of the world there is the Fujiyama volcano, Japan. The Neapolitan volcanic district is composed of the Phlegraean Fields volcanic complex, by the Somma-Vesuvius volcanic complex and by the Ischia Island volcanic complex. In this course, geophysical studies on the Somma-Vesuvius have been presented, referring, in particular, to the correlation between the volcanic activity and the seismic activity. The geological and geophysical setting of these volcanic districts will be discussed in dedicated sections of this lecture. Important studies of this course deal with the Tagoro submarine volcano, located in the Canary Islands, Atlantic Ocean, and with the effects of the volcanic eruptions on the physical and chemical composition of the oceanic water. The Tagoro submarine volcano is a deeply studied site up to recent times. Significant results have been obtained on the submarine volcanic eruptions of El Hierro Island, referring to the physical and chemical perturbation and to the biological activity. In 2017, Danovero et al. Have recently studied the same volcano, publishing an article in Nature Ecology and Evolution, establishing that a submarine volcanic eruption leads to a novel microbial habitat. Near the top of the volcanic cone, marine exploration has revealed the occurrence of massive mats of white filaments. Microscopic and molecular analyses have revealed that these filaments are made of bacterial trichomes colonized by epibiotic bacteria. Surrounding biology suggests that these microorganisms can drive the restart of biological systems after submarine volcanic eruptions. In this course, the exploration of the base of a Japanese volcano will be presented, the active stratovolcano of Mount Zao, located in northeastern Japan. More than 100 active volcanoes occur in Japan, representing about 10% of volcanoes of the world. They are located in correspondence with the so-called Pacific Ring of Fire, whose occurrence is controlled by important geological processes of subduction among plates. The Japanese region is located at the junction of the Pacific, Philippine, Eurasian and North American plates. 5 main subduction zones occur. The Pacific Plate descends under the North American Plate, forming the Coral and the Japan Trenches and controlling the formation of the Northeast Honshu and Coral volcanic arcs to the north. On the other side, the Philippine Plate undergoes subduction beneath the Eurasian Plate, controlling the formation of the Ryukyu and Southwest Honshu volcanic arcs. Contemporaneously, the Pacific Plate undergoes subduction beneath the Philippine Plate, controlling the formation of the Izu-Bonan Mariana volcanic arc. An important seismic activity is associated with these geodynamic processes, often triggering large tsunamis. In particular, the Zao volcano, studied in this course, is located in the northern Honshu volcanic district and is a complex volcanic edifice, characterized by an eruption style that is mainly explosive, phreatic. In the Honshu volcanic district, the Zao volcano is the most active volcanic edifice. It is composed of several stratovolcanoes, which divide the Pacific Ocean from the Japanese Sea. The older parts of the volcanic edifice are represented by the Ryuzan volcano in the western sector of the volcanic district and by the Byobu volcano and by the Fubo volcano, which are located in the southern sector of the volcanic district. In this course, the characteristics of volcanic eruptions in Indonesia have also been discussed. The Indonesian region hosts about 147 volcanoes. The archipelago is made up of more than 13,000 islands, spreading over a large area, and represents the country having the greatest number and density of active volcanoes. The most prominent geological structure is represented by the Sunda volcanic arc, resulting from related geological processes of subduction, involving the lithosphere of the Indian Ocean and the Asian Plate.